time it takes for half of the parent atoms to decay into something else through alpha or beta decay. So example number 1, the half-life of carbon is 5,730 years. So you might hear of carbon dating. This is what they're talking about. They're looking at how much carbon is left, and they can tell when the carbon was created or when the living organism existed. Okay, so what do you expect would happen over a long period of time? So you have a chart here, and at the start, 0 years have passed. After one half-life, you would have 5,730 lives. After 2 half-lives, we would add another half-life onto that, add another 5,730, add another 5,730, and I want you to fill in the chart the same way. Keep adding 5,730. Okay, what you do next is you say, well, if I started with 100 atoms at the start, after one half-life, I'd add half as much, so I would have 50 atoms. After 2, I would have 25. After 3, I would have 12 and a half atoms, but we can't really have 12 atoms, so we would say 12 or 13. I would probably just go with 12. Half of 12 is going to be 6. Half of 6 is then going to be 3. So after 5 half-lives, even though I started with 100 atoms, I'm going to be left with 3 atoms. So that's the concept of half-life. And now we're going to bring into some math concepts. So if you've taken Pre-Cal 30, you've seen this before, but it's not that complicated. Okay, so Marie Curie had 765 sample of polonium-10. 210, and its half-life is 138 days. So same idea, only its half-life is 138 days instead of 5,730 years. So quite a bit shorter in a box, much more unstable. After 3.8 years, she goes to the box to get her polonium. How much is left? So what I did here is I said, well, in 3.8 years, I did 3.8 times 365, and I got this as the number of days. I divided by the number of half-lives, and I said there's going to be 10.05 half-lives. Then I'm going to use this formula here. The amount remaining is equal to the original amount, and I times that by 1/2 to the power of the number of half-lives. So it's always 1/2 because it's the number of half-lives, half. This number of half-lives is a value you put in, and this is the original amount. So you do need to know how this process, you're going to need to memorize that. Okay, so in my calculator, I want 765 times 0.5 to the power of 10.05. Don't forget order of operations. You have to do these exponents first before you multiply by 765. So if you don't get the right answer, that's something you could try. Okay, so when she came back, she only had 0.72 grams. She started with 765, and she was left with less than a gram when she came back. Okay, so now we have lead, 75 grams of lead. Its half-life is 10.6 hours. How long is it going to take when we only have 9.3 grams remaining? So if you're in pre-calculus, this is much easier if you use something called logarithms. If the word logarithm scares you, don't worry, okay? So the amount remaining, that's going to be 75. Half-life is going to go here. We have the original amount. The one thing we don't have is the exponent. So we're going to have to try and find that exponent. Okay, so that's what we have. The amount remaining equals the original amount, 1/2 to the x. And what we're going to do is we're going to guess and check. And so, well, let's think about this. 75 divided by 2, well, 80 divided by 2 is 40. Divided by 2 again is going to be 20. Divided by 2 again is 10. So I'm going to guess 3. Okay? So you're going to guess and check. You're going to put 3 in, and you're going to see if it's close or not. In this case, it actually is pretty close, 3. Okay, if it was a little too much, you would try a smaller number. If it was a little too little. You would just kind of guess and check in that way. Okay, I'm going to show you how to do this using logarithms for those of you who have used a logarithm or those of you that might be interested. So what we do is we divide both sides by 75. Then we take this number, 0.124 is those two divided. And we take the log of both sides. So those of you in pre-cal should say, okay, I see this. Log laws say if the exponent's up here, that's the same as x log 0.5. Okay, now to get x by itself, we're going to go to the log of 0.124 divided by the log of 0.5. And those of you who don't have that, haven't seen this before, you're just entering it in your calculator just like that. Log 0.124 divided by log 0.5 is equal to x, and we get 3.01. So our guess and check was really good. We were really good at guessing, okay? Yeah, that was all you have to do there. Okay, so you have 3 questions to try, and the answers are given. So just make sure that you have practiced doing this because it will show up again on the exam.